Airbus transports its various aircraft parts by efficiently loading them into a specially modified giant cargo plane known as the Beluga. But imagine when it comes to the world's largest passenger plane, the Airbus A380. Its giant wingspan dwarfs every commercial jet built. The components are extremely large and heavy, making transport by any standard airplane impossible, because no cargo plane has yet been built that could adequately accommodate their vast size and weight. Fit this whale-like aircraft inside. So then how are the A380 parts made across Europe? Brought to Airbus's assembly unit. Airbus is a European aircraft manufacturing company that builds 1,000 planes every year and delivers them to airlines around the world. By calculation, that's 3 new planes being built each day. More or less, Airbus has to build 3 new planes every day, which is an incredible challenge. How these planes are ultimately built is a whole other story. But how are the different parts of these planes, made in every corner of Europe? Have the fuselage sections now been shipped to Toulouse, France, where Airbus's main assembly unit is located? Airbus's logistics system combining sea, river, land and sky is known as the world's most complex transport network. Its parts are manufactured in different European countries and then gathered in one place to form a large, beautiful aircraft. This is not an ordinary task, but the result of unprecedented decades of extensive, meticulous engineering and comprehensive global logistics planning efforts in the 1960s. Major European nations such as France, Germany, Spain, and the UK joined forces to envision a new dream. Their aim was to compete with American aircraft manufacturer Boeing by creating an alliance that could produce large commercial airplanes. But this partnership's impact resonates. One of the biggest challenges encountered by the company was that Airbus's numerous manufacturing sites are geographically spread across several major countries in Europe. Each site has its own specialized expertise, and each location manufactures only one specific production section. For example, tail sections are built in Hamburg, Germany, while the central compartment and nose section are produced in Saint-Nazaire, France, in the English city of Bratton. The wings are made, whereas in the Spanish city of Cadiz, there's a factory for building tails. In all these factories, various parts of the aircraft are completed. And that's where a new challenge begins, because parts as large as a football field are sent to Toulouse, France, where Airbus's assembly unit is located. At first, with low Airbus demand, they ship parts by truck and sea, a slow process taking months. But as demand surged well beyond internal capacity, those resulting months-long waiting periods to fulfill customer orders evolved into a bottleneck that constrained the company's growth, especially when they had to produce 3 planes a day. To overcome this, Airbus devised a new and ingenious solution. Scientists recently discovered a solitary whale swimming amid drifting ice floes in the Arctic Ocean, whose echoing call resonates like ethereal otherworldly music. This whale is called the Beluga whale. In 1994, Airbus, inspired by its body shape, created a new plane and named it Beluga. This plane's sole purpose was to transport large-ass, heavy aircraft parts. The Beluga has those features that a typical cargo plane doesn't have. In terms of size and capacity, the Beluga is 56 meters or 184 feet long. Even longer than the full length of an Olympic swimming pool. Its height is 17 meters Ravara or 56 feet, making it as tall as a 7-story building. Its internal cargo space is so vast that inside it, %182 Suzuki Altos can easily fit. When it comes to the loading system, its most remarkable feature is its nose section, which lifts upward like a car's bonnet. This makes the loading and unloading work very easy. A wing pair of an Airbus A350, which measures 32 meters in length, easily fits into the Beluga's fuselage. This single wing pair cost 40 million euros. They amount to nearly 4 billion rupees. So even minor loading damage could lead to losses in the hundreds of millions of rupees. That's why they take extreme precautions at every step to safeguard it. Speaking of speed for parts shipped by ships or trucks, which once took months to reach Toulouse, Beluga delivers those same parts to a European site in just 2 hours. Thanks to this high speed, Airbus's assembly line runs without any interruptions. After this resounding success and positive feedback on the Beluga, in early 2014, Airbus engineers set out to develop an even more advanced version and named it the Beluga XL. it could carry even more parts and larger components. Until then, everything had been going smoothly. But then in 2004, the world's largest passenger plane, the Airbus A380, was successfully launched into airline service. This fuselage measures approximately 8.4 meters in height, while the wing's maximum width at the fuselage attachment can reach up to 16 meters. Now the problem was that the Beluga XL's cargo compartment height is 7.5 meters. Neither the Airbus A380's fuselage could fit inside it, due to the constrained volume, nor could its wings. It's worth noting that the fuselage, which is like a cylinder, is easy to build and join in separate sections, even by relatively inexperienced builders using only basic tools. Whereas the wings are manufactured integrally in a single section because they simultaneously accommodate fuel and essential hydraulic lines, and most of the stress falls primarily on the wing, which is exactly why they are manufactured in a single solid piece, to ensure that no structural weakness or fuel tank leakage ever occurs. In these newly developed A380 aircraft components, to ship them to Toulouse from various parts of Europe. Airbus had even considered equipping the Beluga with a double axle. But there were many issues. For one, they'd have to redesign the Beluga and boost its engine capacity as well, which would cost billions of euros. While the Airbus A380 is so large, the complexity of its design means that not every airline can operate it, which leads to low demand and restricts employment to transporting just a few aircraft. Airbus dropped the idea of the Beluga XL. Now Airbus had to find a new way here. This is precisely where the thrilling tale of the unstoppable super convoy across land, winding river and vast sea begins. Airbus specifically commissioned roll-off vessels so that large, heavy parts could be transported with ease across vast distances by sea. On these specialized cargo vessels, parts are driven on and off using wheels, hence the descriptive name roll-on. Roll-off, commonly called row. Row ships. One such vessel is the city of Hamburg, which measures 126 meters long and 20 meters wide. And its cargo capacity is 5 times that of the Beluga XL. From Germany's Hamburg port, Airbus's large prefabricated hull sections roll directly into the ship's assembly bay on specialized rolling platforms, completely eliminating the requirement for overhead cranes. This ship makes the 1,600-kilometer journey from Germany's Hamburg to the port of Saint-Nazaire. In France, the voyage isn't easy to undertake, as relentless storms and towering waves, reaching up to 5 meters in height, commonly batter ships, navigating the tumultuous waters of the North Sea. And imagine if, because of the ship's movement, wings worth 4 billion rupees were even slightly damaged. In such circumstances, the company would have to rebuild the entire wing from scratch. And so must the ship's experienced captain and dedicated crew. Every 4 hours we inspect the cargo chains. Cameras keep an eye on the cargo around the clock to ensure there's no chance of damage. Upon arriving at France's Saint-Nazaire airport, there's a stopover and the parts are then unloaded. There they are loaded onto specially designed barges. These barges transport the parts via the Garonne River to the French city of Bordeaux. And this is where the biggest challenge comes in, because the Pont de Pierre bridge over the Garonne River has arches that are quite small. This 500 meter long, the bridge was constructed in 1810, and its arches are very noticeably in size, lacking any consistent uniformity. Only arch number 9 is 19 meters wide, through which the barges can pass. But on both sides, narrower openings restrict passage. There's only a few inches of clearance. The ascent problem has been solved. But the arch's height depends on the water level. Although this section of the Garonne River lies 60 kilometers upriver from the Atlantic Ocean, its water level still depends on the ocean's remarkably powerful tidal ebb and flow under normal conditions. The water level here remains high, and as a result, it is impossible for the fully loaded barges to pass through these low arches. But every 12 hours, the ship's captain has only a precious 3-minute window of opportunity at the lowest ebb of the tide when channels briefly open. If he misses that crucial opportunity, the entire convoy grinds to a halt for no fewer than 12 hours, and the Airbus flight schedule becomes considerably delayed. To solve this problem, adjustable platforms were installed on the barges so they could, even during low tide, moving through Arcis was no problem. This was just a small part of the logistics, but it was of great importance. So far you've learned about the sea and river journeys. Now let's move on to the land journey itself. Because Toulouse is still some 250 kilometers away from Bordeaux. By road, this journey kicks off with 5 and 0 meter long super trucks. Each truck packs a 650 horsepower engine and 96 wheels. The bus parts are hauled to Toulouse's assembly unit in these super trucks. But this task is no small challenge. In order to keep road traffic down to a minimum, the entire convoy operates exclusively during nighttime hours. Highways and city streets are closed down. A 40-person team including police, escort vehicles and engineers accompanies the convoy. The convoy's most challenging part is guiding it through small towns, roundabouts and tight corners. One wing dangling 15 meters behind. The truck is just centimeters away from lampposts, trees and rooftops finally. When these parts reach Toulouse's assembly unit, thanks to the high-tech systems here, they can be assembled in just a few hours. The A380, which is the world's largest passenger plane. Over 19 planes, 6 pound of Johnny 0 rivets are used to join its fuselage, and over 4000 rivets attach the wings to the fuselage. After the engine's electronics, interiors and paint the aircraft is now fully ready for delivery. To complete an A380 takes about 9 months for its parts to be made, transported and assembled. To date, only 251 Airbus A380 units have been built. Because operating one isn't something every airline can manage. Surprisingly, 50% of those assets are owned outright by Emirates Airline alone, with no co-owners involved. This aircraft can carry 850 passengers at once. Its takeoff weight is roughly 575 molecule. That's equivalent to the combined weight of 300 SUVs. When it comes to price, one A380 cost 445 million, which is about 3,800 crore rupees. At this price, you could buy 5 aircraft like the Boeing 737. Next time you travel on an Airbus, you'll certainly know the passion and dedication that went into building these jets through teamwork, and then see how all their efforts culminate. How they were transported, playing with danger. We hope you all fully like and share this MTV video. Thank you so much for your heartfelt, thoughtful comments and continued support that brighten my day. See you in the next spectacular, exciting video.